All right, last video of Chapter 8. Yes, excellent. So we're going to be able to apply the side splitter theorem, the corollary of that side splitter theorem, and the angle bisector theorem to triangles. Oh my goodness, this is going to be fantastic and exciting, to say the least. You know what I'm saying? Woo. All right, here's the side splitter theorem. If a line is parallel to one side of a triangle and intersects the other two sides, it divides those two sides proportionally. But the bases are not be able to be used in that proportion, okay? So do not use them with this. Let's talk about that for a sec. So let's just say that this is, we'll call this X, we'll call this Y, maybe I'll call this W, and we'll call this guy Z. What this is saying is I could set up X over W equals Y over Z, or I could even go with the X over Y equals W over Z, right? Either way, I'm still going to get X and Z multiplied, W and Y multiplied. Okay, just make sure you're consistent. You either go from like left, or right to left, or top to bottom, or left to right, over left to right, right? We just make sure that you're being consistent. Don't be like X over Y equals Z over W. That's no bueno. But we can't just use like X over this guy equals Y over this guy. That does not work. That's what it's saying here. What you'd have to do is consider the entire similar triangle and go X over this guy equals the entire side over this guy. All right. So that's not really what the side splitter theorem is about or what it's useful for. You could just set up this, what we have set up right here with those four sides we're talking about. All right. Okie dokie. So the side splitter corollary. It's basically, it works even without using triangles because eventually, let's see here, if we have, we've got all these parallel lines here, and we just got two random lines. Eventually, those are going to intersect if they're not parallel, right, and make a triangle. But what we've got is pretty much A over C is equal to B over D. And if I were to make another set of parallel lines with line 1, 2, and 3, then and extend these guys a little further, let's call this E and this F, I could set that up with E and this is F, okay? And I can even go a step further and say, well, this whole part is over this whole part. Those guys are proportional. So you could even have in there B plus E over D plus F, whatever those values might be. That could be a part of this super proportion that I've been creating over here, okay? Awesome stuff. All right, one last theorem here. It's the angle bisector theorem. It says if a ray bisects an angle of a triangle, it divides the opposite side into segments that are proportional to the adjacent sides. What the heck does that mean? Let's use some letters again. Let's call this W, W, X. Call this guy Y. That does not at all look like a Y. There we go. And this guy's Z. So what it's saying is that I could set up a proportion of Z over W equals Y over X. Cool? I could also, another acceptable one could be W over X equals Z over Y. And you'll notice, once again, Z and X are getting multiplied here, same here. W and Y. W and Y. That's why it still equates to the same thing, all right? So you can go, let's see here, up and down equals up and down, or I can go side to side equals side to side, okay? Just don't go like around like we were talking about. All right, now let's use them. So it says if BD, the wonderful weird writing, ray BD is an angle bisector, find AC. I'm looking to figure out what AC is, not just X, okay? So I can set up a proportion. I got a couple options here. I could do 8 over 16 equals 5 over X, or I could do 8 over 5 equals 16 over X, whatevs. The reason why I did this is because I noticed that I could simplify this to 1/2. Now my numbers are real easy to work with. So I've got 1 times x is 1x equals 2 times 5 is 10. So x equals 10. Why don't I just turn that into part of my circle? All right. Or my box, rounded box thing. So that's what x is, but is that my final answer? No. This is 10 here. AC equals 15. This is my final answer. I will double box it and add in another color and then another color to make sure that's clear. Okay, that is my final answer. Don't be tricked into thinking that 10's your answer. If this is multiple choice, I guarantee you that would be there, all right? But it's not the right answer. This guy that's been boxed multiple times, and for good measure, let's throw a couple more on there. Whee! And maybe another one to end with that wonderful purple that is totally out of the ordinary of all the others. Okay, there we go. That is my final answer. And that was my angle bisector theorem. Angle bistheorem. Cool. So we have triangle ABC. AB is 12, BC is 9, and AC is 14. And BD is an angle bisector. What's DC? Well, let's draw a picture here. It says A, B, C. AB is 12, BC is 9, and AC is 14. It says that BD is an angle bisector. Not a segment bisector, but an angle bisector, right? It cuts that angle into two congruent angles. What's DC? Well, this guy right down here is point D, right? That is D. Well, how am I going to figure this out? Well, if I want DC, why don't I go ahead and let's just call that segment X. DC is going to be X. I could use my angle bisector theorem to set up a proportion. I could do 9 over 12 is equal to X over, well, what's DA? It's not 14, it's 14 minus X. Ooh, got to get creative. I'm going to simplify this guy down to, is it 3/4? 3/4? A little bit easier to work with now. I can cross multiply the 14 minus X. That would give me 14 times 3 is what, 42? Minus 3X is equal to 4 times X, which is 4X. I would add the 3X. 42 equals 7X. Divide by 7. I know that X is 6. Woo! That was pretty cool. That was awesome. And I set X as DC, so that is indeed my final answer. Alrighty, find the sum of X and Y. I love these types of problems because it's like, oh, I don't just have to solve for X and solve for Y. I got to sum them, meaning I got to add them. That would be the better way of saying that, not sum them. We got to add them together, to get the sum. All right, so let's do that. How about, I think I see a way to solve for X that I like. If I did the side splitter theorem, 9 over 12 is equal to X over 6. Again, I could simplify this guy down to 3/4. I just saw that ratio before. What's 3 times 6? That's 18 equals 4X. If I divide by 4, oh my goodness, that doesn't divide perfectly. I'm going to cry. I don't care. 4.5, right? 18 divided by 2 is 9. Divide that again is 4.5. Excellent. All right, so we've got 4.5 for X. Well, what's my Y going to be? How do I set that one up? Well, I can't use the side splitter theorem when it comes to the bases, but I can think about this in the context of similar triangles. So I could do 12 over Y is equal to my entire side, which is 18, over 22.5. Okay? So now I can cross multiply and solve that bad boy. 12 times 22.5, that's going to be 270 equals 18y. Then I'm going to go ahead and divide by 18, and I get y equals 15. Okay, but remember my actual answer is the sum. I got to add those together. So 15 plus 4.5 is 19 0.5. There is my final answer. And the theorem we use there, side splitter. Along with similar triangles, right? Okay. We got ourselves a little doozy looking thing here. It says KP is 27. Find Km. So I'll just go ahead and call that guy X. What the heck do I do here? Well, if you remember what I said about the side splitter theorem corollary, the one that looked more like this, where I wasn't really dealing with necessarily a triangle, you can combine multiple sides together. You just have to make sure that it corresponds to the other side. So I've got 2 over x, is equal to, well, what corresponds to the 27? That's all the way from f to j. 2 plus 3 plus 4 is 9. So this whole part right here is 9, and that's over 27. And I can go ahead and simplify this guy down. 9 over 27 is 1/3. So 2 times 3 is 6, equals 1 times x, which is x. X is the part that I'm looking for because I labeled Km as x. Okay? You guys, that could work for anything. I can give you a separate problem here. What if I wanted MP? What if that's what I wanted? Well, MP, let's call that guy y. I could do, let's see here, 7 over y is equal to, and I could use the 9 over 27, cross multiply and solve. Again, that right here is 1/3. That's what this guy is reduced. So I'm going to get 21. 3 times 7 is 21 equals 1y. And I could get MP that way. All right? And that actually does check out 21, 6. That gives me 27, right? That adds up to what it should be. But again, it works in multiple ways. You just got to make sure that you are setting it up correctly. Don't mix things up. It takes a little practice.